Hi, this is a short video just to look at an integral here which involves using trigonometric identities to solve. So it's just tan cubed. It seems quite innocuous, but as you'll see, the result that we get is not trivial. So where do we go with something like this? Well, if we've got powers of tan, then what we'll do is we'll use a Pythagorean identity. And in particular, we've got this one, tan squared x plus 1 equals sec squared x. So if we rearrange this, then we get sec squared minus 1, and we'll substitute that in. So we're going to write this integral as tan x multiplied by tan squared x. So if we substitute in the identity, like so, then we can write this as tan x times sec squared x minus tan x dx. Where do we go from here then? So we've got two integrals, so let's solve them separately. So first of all, we've got minus tan x. Let's deal with that one. So minus tan x. This one is fairly easy to solve. We just use the very fundamental identity that tan is sine over cosine. I'll put the minus sign outside. So we've got sine over cosine dx. And what we need to recognize here is that we can write this as, what we'll always try to do if we can, is spot that we can write a function of a function, and then the inner function, the g of x in this case, does the derivative of that appear somewhere? If it does, if we have an equation that looks like that or proportional to that, because we can always move constants outside, then the way to solve an integral like this is a u substitution, where u is the inner function g of x. So let's look at what we've got here. We've got sine x and cos x. So what we want to look at is the cosine x on the bottom here. What's the derivative of that? And the derivative is minus sine x, which appears on the top as a multiplier. So if we choose cos x as our choice of u, then we can say that du by dx is equal to minus sine x. So du is equal to minus sine x dx if we treat that like a fraction. And we can see that that's what we've got on the top of here. We've got minus sine x dx. So we can write the integral as simply 1 over cos x, but cos x is u, so 1 over u du. And this is a standard result. This is just the logarithm of u, which in this case is cos x. So ln x, and then I'll put plus c on there. Okay, so that's the first one done. What about the more complicated expression, tan x sec squared? So let's look again at what we've got here. We've got tan x and we've got sec x. What are the derivatives of those? Well, we know that d by dx of tan x is sec squared x. Oh, and look, that appears in there. So we could use u equals tan x as a way of doing this. We've also got sec x there, of course. So we could say d by dx of sec x, and we know that that is sec times tan, which also appears. Okay, so there's actually two different ways to solve this. So I'll indicate this in two different colors. So we can, first of all, we can write this as tan x times sec squared x, and let u equals tan x. So du is equal to sec squared x dx. So the integral becomes simply u du. So a half u squared plus c, and u is tan x, so half tan squared. So that's one way of going about it. The other way of going about it is to write, I'll rewrite the integral in a slightly different way. We'll write this as sec x sec x tan x multiplied by sec x. So looking at the general form that I want for a u substitution in the top right there, you can see that I've got sec x. Okay, so there's my function of g of x. In this case, it's just to the power of 1. That's not very exciting, but there it is. And then the derivative sec x tan x appearing. So I can just say u is equal to sec x. And so du is sec times tan dx. And so the integral simply becomes u du again. So we're going to get a half u squared again, so that's a half sec squared x plus c. And that's not the same as what we got before. However, we know from this identity at the top here that tan squared and sec squared are equal to each other up to a constant. So what we've always got to bear in mind with integrals is that these constants of integration are not the same constants each time. So the -1 that appears in the identity will be subsumed into these constants of integration, so that the overall expression at the end are equivalent. So there are two ways of writing the answer to this problem. We can say that the integral is either a half sec squared x plus ln of cos x plus c. I'll write that c1, or a half tan squared x plus ln of cosine x plus c2. And just recognizing that these c1 and c2s are different, but both of those are equal. If this was a definite integral, and you wouldn't have the c1s and c2s, and the numerical value that you calculate would be equal in each case. Okay, there we are.